So the rise of cloud computing prompted this need for these databases, and they could leverage the flexibility of it, the scalability, and the cost efficiency. Those were the primary reasons for these cloud databases. They were completely optimized and supporting large-scale applications. We also have edge databases. With the growth of IoT and edge computing, IoT devices were there everywhere now. There's a lot of sensors around. There is a lot of, we talk about robotics, we talk about drones, we talk about sensors, autonomous vehicles. Everywhere the data is coming for every nanosecond, actually. So how are we going to store this data? And how are we going to process this data? So that's where we needed a lightweight, resource-efficient database, which is called an edge database, that is embedded in the embedded device itself, actually. And it gets synchronized in real time with its parent database, actually. So SQLite is one such embedded database in mobile and IoT devices. So they mainly focus on low latency for their minimal resource usage, for local data processing, and reducing the reliance on its central cloud service. So this is all about database evolution. We'll just move to then, we just saw about OLTP, OLAP, and hybrid transactional analysis databases. So this is a picturesque view of how exactly these databases are put across. When you talk about storage systems, so primarily it is divided into online transactional processing, hybrid transactional analysis processing, and online analytical processing. So under OLTP, you have structured query language and NoSQL. So under structured query language, we all know about relational database like Oracle or DB2. And NoSQL, as we talked about, due to the spurge of internet usage, it got divided into, based on its convenience, it got divided into key value store, document store, graph store, and multi-model store. So every database has its own purpose. And the other one is the NewSQL, or hybrid transactional analysis processing. So this is combining both the OLTP and OLAP world, combining the advantages of both these OLAP and OLTP. That's where this hybrid transactional came into picture, which is also prevalent for its own requirements and use cases. When we get into analytical part of it, actually, online analytical processing, because we have all the data which is coming from OLTP, banking system, or retail industry, or autonomous automotive industry, actually, or healthcare industry. So wherever you see data is there, data is coming from your end-to-end client usage, but how are we going to make use of it, actually? So that's where analytical processing came into picture, and you have columnar OLAP databases. You have time series databases where it needs to be time fixed. What exactly happened 10 years back? What exactly is happening now? Based on the history of the data, you'll try to identify the data patterns and you can predict what the future is. And the other one is real-time OLAP. Real-time OLAP is you just need to know as the data comes in, you need to process the data as it comes in freshly. You need to understand what exactly it has, and finally you need to make a sense out of it, see if it is really good or not, and based on that you make a decision making for the industry. Something like, for example, if you want to, in the banking industry, what they say is, but if you go for a loan processing, they take few days. Previously it was taking a week's time. Nowadays it takes a day or two, but they wanted to give a loan on a real-time basis. You just go with a loan application, they feed in your data completely, based on your CIBIL score, based on your risk appetite, based on your collaterals you provide. They just identify how good this customer is, how good he can repay the EMIs. Then immediately they'll just process it and just give the loan in the next minute itself. So that's the real-time processing we are looking at. So this is one thing in the finance industry. Similarly, if you see, this is with regards to the banking industry. With regards to the finance industry, if you talk about anti-money laundering use cases. For example, if something is happening, if someone is suspiciously transacting, if someone is transacting 1 crore or 10 crore money, if he is sending from one account to another account to Bangladesh or neighboring country, which is war prone, then that is something to look at it actually. So this data is not a normal transaction. Something is happening. There might be some spy going on or some extra thing happening outside. So we need to take a look at it immediately. So that's where this real-time processing comes into picture, and that's where these databases come handy for us. Yeah, so to get into key database solutions, online transaction processing, I think we just know they are designed for managing day-to-day transactional data, and they are high transactions. The characteristics of online transaction processing are they have a high transaction speed and ensures asset properties, atomicity, consistency, isolation, and durability. Primarily, use cases are banking, e-commerce, and order processing. The SQL databases, which comes under OLTP, they are best for structured data and complex transactions. They have a strong data integrity actually. You can have constraints to it actually. You can referential constraints you can have unique key constraints. So these are all these helps in data integrity so that there is no duplication of data here. There is no duplication of data which is more resource intensive. So here the data is quite relational. You have a structured query language to retrieve the data, to do some reads and writes, and to do some updates. And you have a predefined schema, how exactly the data has to be stored in these tables, how many attributes have to be there, how many rows will be there, and what columns should be there. So these are all predefined. And the tables with rows and columns, and they have a strong ACID compliance and supports complex queries. You have nested joins, you have multiple joins, you have subqueries and all those stuff. So example, as we all know, it is MySQL, PostgreSQL, and Oracle. These are widely used today in big enterprises actually. Big enterprises, they wanted stability. They wanted stability for their ongoing business, and the SQL databases provide that actually with all these properties, in addition to the security they provide to the data. NoSQL databases, if you see for online transactional processing, it's ideal for unstructured data. Talked about, it is high in velocity. Every second it changes actually. There is a tweet every second actually. There's hundreds of tweets coming into HDFC Bank. Either it can be a good message or it can be of customer complaints. So there's a huge velocity. How are you going to address that actually? So that's where you are going to store it, to store the data. You need to scale horizontally based on the data that is coming in, and it supports distributed architecture. So you have multiple servers which process the data actually. So they are non-relational and they are flexible for handling unstructured and semi-structured data. So they are schemaless and they're flexible data models. Based on the data that comes in, they're flexible enough to accommodate any kind of data format. They're highly scalable and designed for distributed systems, as we talked about. The primary examples are MongoDB, which is document-oriented, NoSQL database for unstructured data, Cassandra, and NoSQL database optimized for high availability and large data volumes. And Redis is an example for key value store for fast and in-memory data processing. So we'll just quickly get into spend a few minutes on what exactly this online NoSQL databases each one has in store. So key value databases, as we talked about, Redis is one good example. DynamoDB from Amazon is a cloud database, and that's also a key value database. It's highly scalable actually. As the data comes in, it handles large data sets efficiently through horizontal scalability. One use case I could think of here is when you have an Amazon Prime sale or a Flipkart sale. So at that 3 days, the data that is coming into the Amazon servers are huge actually. There'll be millions of orders. As the data comes in, you need to constantly process it, and you need to have the storage and capacity to process that, and that's where this high scalability comes into picture. And caching the database actually. The system performance by storing frequently accessed data. So the caching mechanism in the database has to be good enough so that the frequently accessed, they need to know what was your recent transactions, what was the recent access data. And the data structure, how exactly the data is getting stored in key value databases, it consists of key value pairs, but each key is unique and points to a value, which can be a number or a string or any other key value pair. And it's suited for large databases dealing with simple data, commonly used in caching data, managing user sessions, advertisement servicing, and recommendations. The next one is document database, actually. So they accommodate unstructured data with varying data formats, allowing easy for schema evolution. And they're hierarchical structures. They support nested and hierarchical data structures, enabling rich and flexible data modeling. And they support horizontal scalability. The document database scale horizontally, making them suitable for distributed environments. There is no strict schema, as we talked about, and it supports multiple data formats: JSON format, BSON format, and XML format. Supports multiple formats, and it can be used for managing user profiles with varying attributes. Commonly used in applications where flexible data modeling is essential. MongoDB is widely used today. CouchDB and Elasticsearch is also used as part of the document database. The next one is graph database. So graph database, it consists of two elements, mainly the nodes for storing the data entities and edges for storing the relationship between these two entities. So it helps at managing the complex relationships and performing graph traversals efficiently. So data will be stored in different nodes in the graph. As we might be knowing a two-dimensional graph or be knowing multi-dimensional. This is kind of a multi-dimensional graph where each and every node is storing a data entity, and the edges are storing the relationship between the entities. So this helps in fast queries for highly connected data, making them suitable for recommendation systems and social networks. Social networks is one thing where this graph database is highly used. So it helps in dynamic data modeling, actually. Helps. The data modeling it's very flexible. As the data comes in, it can add the data based on the data format that it comes in, actually. The nodes and edges have defined properties, and by using these properties, you can query the data easily. So the most widely used graph database is Neo4j and Redis Graph. So this is widely used in financial industry where you can see know your customer, KYC, or when you see anti-money laundering applications. This graph database tries to identify what kind of transactions the customer is coming in, actually, and what is the relationship between these two transactions. They can easily get this information. In-memory databases. So this is about database doesn't have a persistent data storage. It is mainly primarily on the internal memory of your data storage. You store the data in the memory so that there is no direct read-write access to the file system, actually. It stores in the RAM, or random access memory, or the primary memory of the database, and it enables faster data retrieval and processing. It's well suited for real-time applications that require low latency access to the data. And it offers exceptional performance for data-intensive operations. So the examples are SQLite is one of the main databases, and Apache Derby, Amazon MemoryDB is also other widely used in-memory databases. And Memcached is a general-purpose caching system, and it's a distributed database to make database-driven websites faster. So primarily, it's a low-latency databases. Most of the data and most of the use cases where it fits in is you need to access the data faster, and the data should be available at the earliest, actually. And yeah, this is an interesting database as we are using today's world. It's an embedded database, actually. So it is tightly as the proliferation of IoT devices, Internet of Things, keep moving on. There's a lot of, as we talked about, there are a lot of sensors coming in. There are a lot of embedded devices everywhere. We see Alexa here. We have a BLDC fan. We can remotely operate, actually. Everywhere you have sensors in our house today, and it is always giving us continuously giving the data to us. So these databases, they're tightly integrated with the application software. These embedded systems often have very limited computational power because of its size and computational power. The databases are designed to be pretty lightweight and they're high performing to match these constraints. So it's also called as an edge database. It's a type of embedded database optimized for resource efficiency on a decentralized low resource devices. It need not go do the processing at the central server, which is located, because you'll be losing time. There is a latency time delay. All it does is it does the processing within the local device itself, actually. That's what it's all about, the embedded databases. Example includes mobile databases supporting Android and iOS systems. It efficiently manages the growing number of embedded devices in industrial and consumer sectors. If you see in the manufacturing sector, so there's everywhere you have your sensors coming in, and sensors are there everywhere to identify, to improve the efficiency of the whole process. So wherever we have started using the sensors to improve the efficiency, to see how exactly if the camera is there to capture who is there at one particular point in time, who is working efficiently. So this is one kind of an information. If you see how the weather is changing on a given day, actually, how the weather is changing on a given month, how is the climate performing? So these are all, you have sensors, weather sensors, or temperature-related sensors, which keep sending data to the, and then you try to process it and deliver out, give information based on the processing. So here the performance is quite critical, and embedded databases need to operate efficiently on devices with limited CPU and memory. So the reliability is also important because these devices is prone to power failures, or it may not work at any point in time, but we need to make sure that reliability is ensured so that the data is not lost. That's where the synchronization comes into picture, and how well the synchronization of each of this database will matter a lot when you identify what database to select here. And it also comes under ACID compliance, the atomicity, consistency, isolation, and durability. This ensures the data integrity and the recovery of the event if there are any issue pops up. SQLite is a commonly used embedded database known for its lightweight and resource efficient design here. So we talked about the OLTP databases till now, and then now I think we'll get into the hybrid transactional databases or NewSQL databases. So here it's primarily we are trying to get the advantages of both OLTP and OLAP databases together. That's what this hybrid transaction analytical processing is all about, and the NewSQL is also all about. So it's transactional as well as analytical, leading to delay. So traditionally, because the transactional and analytical systems are separate, there is a delay in making decisions, actually. This delay can hinder a lot of real-time opportunities like predictive analytics, where we need immediate data. So to overcome this HTAP, hybrid transactional analysis processing database, it unifies both transactional and analytical data in a single system. It eliminates the need for a complex ETL process, which is extract, transform, and load process. It provides real-time data access for analytics and reducing operational complexity. It helps organizations to capture time-sensitive opportunities. So, and then focus on IT resources, primarily when, if there is any, as we talked about, an Amazon Prime Day is coming. So it tries to address both the online transactions, and it also tries to address the analytical part of it and see what is so demanding at the moment, and what is that where I can give more offer to these products so that the consumer is buying more, actually. So these are all use cases where, based on which how the data is there, how it can be processed. That's where we combine the both OLTP and OLAP functionalities together here. So the NewSQL databases, it combines the relational model from NewSQL and the scalability of the NoSQL databases. So it uses a dual layer architecture, both the relational and the key value store, and it brings the advantages of both SQL for its consistency and NoSQL for its scalability and flexibility. Snowflake is a prime example for these kind of databases. So the next part is OLAP databases. I think this is primarily for analytical processing. It's mainly time series data, data points recorded or for specific time intervals used to identify the patterns and trends over time. It's widely used in statistics, signal processing, pattern recognition, and weather forecasting. So based on the history of the data, what we can forecast. That's what this OLAP database brings handy to us. So there are multiple time series databases available, and they're designed to handle, so the data is timestamped and comes with specific time intervals. They provide fast insertion and retrieval of data, and it supports complex analysis. Examples are InfluxDB, Apache Druid, or main examples. The use cases, as we talked about, the weather data, the stock prices actually. Stock prices, what is the stock price in the morning? What is it after 1 hour? And IoT devices, as the data comes in, from time to time, we just store it and we just analyze how the data is behaving. The other one is streaming databases. This is also quite interesting in today's landscape. So these databases handle large volumes of data in real time, and it's generated or ingested. They're optimized for continuously changing the data that arrives rapidly. So as the data is streaming, they're used in real-time analytics actually. Fraud detection is one main thing we talked about. So when there is a transaction happening, it has to be identified whether there is any suspicious involved, and then it has to be alerted properly. Monitoring systems. Most of the monitoring systems need to have a streaming databases and alerting systems and recommendation engines. So as and when you start browsing your Instagram, you know what whose profile you are going through and which company's account you are going through. The recommendation engine will be processing simultaneously, and it will be just giving you what exactly you are looking at. That's how it is. So the timely insights are critical for these applications as the data constantly changes. So examples are Delta Stream and Rising Wave. These are quite prominent here. The use cases, I think, it's basically primarily in the finance, e-commerce, and supply chain management. So databases like Snowflake offer real-time functionality for processing and analyzing data as it gets generated. So here we saw OLTP, OLAP, and HTAP databases. Now we'll see what exactly AI integration, how artificial intelligence, which is the hot thing today, what does it bring to table when it gets integrated in database management systems actually. So what it does is it enhances the database efficiency. It optimizes the query performance. We are going to see how it's going to do that. And it also automates the routine management tasks. So you have a lot of data in your database. You have multiple databases in your company. You have a SQL database, you have a NoSQL database, you have a HTAP, new SQL databases. Everything is implemented for its own requirement. But how are we going to use it is, again, which will help in business intelligence and decision making. So that's where AI comes into picture, and the natural language models which comes with AI and the machine learning models which comes with the AI helps to go read the data, identify the patterns, and see how it can help the end user decision making. So how AI is being integrated into databases. So there's multiple things that is coming up. There are a lot of research going on, but still coming into the real world use case, there are a few things which is slowly popping up. This intelligent databases interfaces. As we talked about, if I am as a data analyst, if I want to see the data across my enterprise, and if my enterprise is having multiple databases, I want to see how exactly each data is being stored and how I can query and make use of it, then intelligent database interface is one thing which will help you based on its natural language processing models. The next one is learnable databases. So databases, they've started learning actually. How exactly a user or a company is using the database, based on it, it will try to identify what is more frequently used data, what is less frequently used data, and where is the redundancy of the data, where is the duplication of the data. These are all the patterns it will identify by itself, and it will try to figure out what has to be prioritized more. That is what is all about learnable databases. So it incorporates machine learning techniques to adapt and optimize their performance based on the data patterns and user interactions. They learn from past queries, they learn from data access patterns, and the optimization techniques are useful to improve the future performance. The next one is smart query processing. The AI algorithms are used here to optimize the query processing in the database, actually. So machine learning models can learn from the past queries, and they'll see what kind of queries they have written, whether they have proper join conditions, whether they have proper predicates, whether they have proper filter conditions, what kind of execution plan should I use. So these are all smart query processing. So you can just, whatever the query that you write, it will try to make based on the information it has or the knowledge it has, it will try to write on top of it and execute the queries. Data integration and metadata management. So here, the AI-powered tools can automatically detect the data from various sources. You have multiple sources. It will detect the data from various sources and integrate them based on different formats it has. And it provides a unified view of the data without any manual intervention. So the machine learning algorithms, it helps in identifying a similar or a matching record patterns within the multiple data sets. Even when dealing with incomplete information, if it's there, still it will be able to identify a unified view of the data. Anomaly detection and security. This is quite important in today's world because there's huge data, and it will try to prevent anomalies and fraudulent queries, and see if there is any suspicious query that's coming in place. This could result in data breaches because there's a lot of sensitive information there. If I just want to see the balance of my bank account, or if I want to take all my email IDs or my phone numbers or my bank balances, all your personally identifiable information, PII information, these are all quite private. And if there is anything that is coming in place to access these data, so with the help of AI, we can detect it and the data can be protected. Personalization and recommendation. So you can analyze your behavior and preferences, and this helps the applications to deliver personalized content and recommendations. This we see in all our Insta feeds or YouTube videos or Facebook feeds. So MongoDB Atlas is a database. It uses the AI to provide personalized content and recommendations to the user. So on the whole, if you see, the integration of AI to the database represents a significant advancement in the data management. It enables more efficient, intelligent, and secure database systems. So as the AI technologies, they're continuing to evolve, we can expect to see even more innovative applications when AI and DBMS are merged together. So here, a typical table, it differentiates how exactly a traditional database and an AI-powered database is different from. With the aspect of data storage and retrieval, a traditional database, what it does is it just data stored based on the schemas and structured queries. On the AI-powered databases, it supports unstructured data and uses NLP, natural language processing, for querying. Sometimes what they say is they're also experimenting. You need not write any query. A business user need not have any technical knowledge. They can just ask, okay, just give me the average balance of the customer for this quarter. So if I just voice it out, it will convert the voice to text and it will get the output of it, actually. That's how this natural language models are getting developed as of today. Query optimization. So the traditional query optimization techniques are used in the traditional database, like a cost-based optimization or a rule-based optimization. But in the AI-powered optimization, the machine learns by itself actually what is the best access path and the shortest access path to retrieve the data actually. So how much should I do a full table scan or should I do an index scan? So these are the things AI knows by itself so that it gets the query in the fastest way possible. And real-time insights. The real-time data processing capabilities are very limited in your traditional database. But in an AI-powered database, the real-time data processing and provides instant insights are possible with the help of AI and the models that it continuously runs on top of it. Scalability can be complex and may require manual intervention in a traditional database. But in an AI-powered database, it's automatically scalable and handles growing data loads very efficiently. It can understand, it can figure out based on the demand. If the demand is high, it can just throw in few servers at that moment. And suddenly if the demand drops within an hour, it can spin off the servers as well within the same hour actually, just a matter of time. And natural language interfaces typically lacks natural language interfaces for a traditional database, but with the AI-powered database, it incorporates NLP for intuitive querying using everyday language. Normal English language can be used for an intuitive querying to get the data across multiple data formats. So this is one other interface based on the AI that I was just, I happened to take a look at it. So what it does is, we talked about the multiple databases below, and so there is an IDA, intelligent database interface, which works behind. It doesn't know how many databases are there behind actually. You have a single schema manager, which manages all the schemas. You have a single query manager, which handles the queries and which also reroutes the queries to the different databases that it's supposed to go and get the data from. And you have a connection manager as well, which works with both the schema manager and the query manager to combine the data, get the data, and give it to the user. So it gives a one single view. So that is what is intelligent database interface. It's quite exciting, and hopefully it will come any time in future, and we should be able to use it when we have multiple databases to work with actually. So these are, I think, the intelligent database interface is more user-friendly and it's quite intuitive, and it uses this natural language interactions with database. And these learnable databases are more adaptive because the user queries and user trends, optimizing the data organization, they do the indexing on their own, and they also enhance the query performance. Oracle has done this autonomous database that they've brought around, where what exactly it does is it will try to do similar kind of work, and they're trying to enable the routine data work that they're supposed to do. They'll do the backups, they'll do the archival, they'll do the configuration management, and they'll try to see what best parameters to use, parameter configuration within the database. It can be configured based on the data workload that the server is handling. So the influence of the AI and machine learning models in the database is quite huge, and we will be seeing all these things in future. Even currently it is there as well. It enhances the data analysis capabilities. So this natural language processing and the image recognition helps the business to derive deeper actionable insights from their data actually. So when there is unstructured data in your NoSQL databases, these AI and machine learning models try to go and see what kind of data is there in the image files, what kind of data is there in your video feeds, what kind of data is there in your Twitter feeds or Facebook feeds. It will try to analyze that within seconds or within minutes, and it will try to come out and give you the results for you. It helps organization make informed decisions, identify hidden patterns. These are quite important. The patterns of the data are quite crucial for any business to improve their operational efficiency and to adapt to the market changes swiftly. So data analysis with AI is going to be very crucial, and identifying the hidden data patterns is even more prominent and important in the business scenario. Predictive analytics. So this is always the thing which is happening at the moment. By using these machine learning models and by leveraging the history data we have stored in ourselves in the data marts or data warehouse. So we try to predict the trends. We try to predict, so from which area, again, I'll take this Prime example, Amazon Prime example, from which area the demand is more for refrigerators. From which area the demand is for, if you go to banking, from which area the demand is more for educational loans. So these are all the behaviors we can study, and then we can see how we can competitively position ourselves with regards to our competitors. So these are all predictive analysis, which the machine learning model does by reading the history data and behaviors. Customer behavior. So customer behavior, what exactly I am interested, what kind of data I am interested in when I just get into any kind of an industry, how exactly I'm using the data and consuming the data. These are all captured. These are all the patterns. Every customer, they have their own pattern. So when the pattern is identified, the companies can target the audience based on their patterns. Okay, if I like only what these if I like only the clothes from Walmart or clothes from only if I like only the clothes from Lifestyle, then those kind of ads will keep coming in actually. So, and financial forecasting, how exactly the interest rates are changing, what is the pattern previously, and if this is the pattern, am I forecasting a recession going forward? Is there going to be a downtrend in the market? So these are all the predictive analytics based on the information we have, and machine learning models and AI models are completely helpful in this scenario. It enhances the business forecast and in decision making. It improves customer experience. And how the data is getting optimized with the help of AI. So as we talked about, the database, the performance of the queries are optimized. It knows, for example, if I'm not using in my query, if I'm not using a column where the index is actually there, it'll try to see how it can incorporate and how it can use the index, and it can restructure the query. And how the execution plan is happening, whether is there, how many paths it is taking care, and what is the cost of the plan? What is the cost of the execution plan? It will identify and see what is the shortest path available to retrieve the data and give the data to the end user actually. And data storage strategies. This is quite crucial today because the storage is huge as the data comes in, but there is a lot of redundancy in the data actually. How the data is stored at the block level, segment level, at the table space level, or at the flat file level actually. So if there are a lot of spaces or the redundant spaces there, then there will be a huge processing power involved to retrieve the data. So when you know that the data is densely populated or when it is sparsely populated, it will try to figure out how to get the data in an efficient way. It reduces the response time and minimizes the resource consumption. Resource consumption is quite crucial here because this lowers the operational cost of the business. And again, query optimization, we talked about the history of the data to predict the trends and behaviors. And yeah, I think it is the same thing that is coming here. Customer behavior, inventory needs, and it helps in business forecast and decision making. The real-time data processing, I think we also touched upon earlier, meaning why the streaming databases was quite helpful. So as AI facilitates real-time data analysis for immediate insights, everything is quite immediate today. As today's world, we all need immediate results. Instant gratification is the thing actually. So where exactly I'm looking at and what accounts am I looking at, and dynamically the decisions have to be made, and real-time data processing is one thing which comes into picture. Apache Kafka and Apache Storm these are the frameworks which help in real-time analytics. And mainly it supports fraud detection, recommendation engines, and IoT applications. It enhances the responsiveness, and user experience is the thing today actually. How the user is feeling today actually. What exactly, because if you show something which is really pleasing to me, that's where I go to. And this is quite prominent today to catch a user and to hold the user for any business. And automated data management. It's used to automate the routine tasks. So the routine tasks will fade away because there will be a user, there will be a database administrator who will be helping in backup. He'll be helping the data retrieval. He'll be helping in archival. These are all routine manual tasks which can be automated, and AI does that quite efficiently. And auto indexing and auto tuning and data curation. So it tries to identify which columns or which data has to be indexed properly and what kind of indexes have to be, whether it's a BT index or a bitmap index or a hash index. So these are all automatically decided based on the data fetching and the data queries, and it does that properly. as a part of data management. It reduces manual oversight, which helps in error reduction and increases operational efficiency. Yeah, 90% of industrial strategies are mainly emphasizing information as a crucial business asset and analytics as an essential competency. So for any business to thrive in the scenario today, the analytics is quite needed, and the information, meaning information, if you say it's a useful information, has to be there actually, and AI plays a major role here. And as a part of the data management, which we saw earlier, how do we maintain the data quality? Because data quality can be, because there are a lot of manual interventions when the data comes into a system. There could be null spaces, there could be nulls, there could be blanks, there could be spelling mistakes. When a human comes into picture, there could be all sorts of issues or all sorts of errors actually. How are we going to address that? So again, that's when AI will try to identify what is the exact data value which is there, and it will try to replace with the correct data. It will ensure data quality is precise, and it will understand the data's health, and it will find ways to improve the quality of the data. And when onboarding the new data source, for example, today I'm getting into a new business, when the new data comes into my data warehouse or a data mart or a data lake, it'll try to identify what is the new data identifiers, and it'll try to integrate the data to the existing data warehouse. It's quite seamlessly it is done. And the next one is data discovery and matching. Again, with the AI technologies and machine learning models, you find specific data fields and data matching becomes very seamless. It not only reduces the data duplication, but also increases the data accuracy in the data source. So there's multiple data duplication is a big issue, because when you try to get the data, if there is a duplicate data, there's a lot of operational efficiency because it goes and fetches data wherever it finds a matching pattern. So that is avoided here. Use cases of AI is personalized recommendations, fraud detection, as we talked about, patient diagnosis in healthcare. This is quite upcoming thing, because as and when we take an MRI scan, as and when we take a CT scan, you just go there and immediately you get a result out of it saying that, okay, this is what it is. So if you go for a biopsy, for example, based on the information the data has and what kind of DNAs are there, what kind of sequencing is done in the DNAs, you try to come out of it and give the results in no time, which is going to save a life for a person. And autonomous decision-making in autonomous vehicles. Multiple studies have been going on for the last few years. Based on the sensors an autonomous vehicle has on its car, Uber is the main thing, and Lyft is the other one in the US. They're coming up with autonomous vehicles, and they try to see where exactly the obstacle is. How do I park a vehicle when there is no driver in the car? So it needs to take a decision. Should I go back? Should I go to the right or the left? Based on the information that it processes from all the sensors, it is there within the car. So what is the industry benefits that we are getting based on the AI and database integration? What exactly it does, and what kind of industries are getting benefited out of it? It enhances the data management, as we saw in the previous slides. It improves the operational efficiency, helps in decision making for sure. And data security is also taken care actually, because it identifies what is my personal identifiable information, and it tries to ensure that if there is an access coming to the system, targeting that particular information, it's trying to create an alert system out of it, and it will try to ensure data security. And the industries which are really getting benefited out of this AI with database integration is healthcare, because it allows comprehensive view of patient information by consolidating the data from all the electronic health records, medical imaging and genomic data. This integration helps the healthcare providers make accurate diagnosis. They give specific treatments, actually, tailor-made treatments to the patients. And they can anticipate potential health issues and help them in coming out of the issues. In finance sector, if you see, risk management and fraud detection is the main thing. Like they try to do a KYC. They will improve the security and compliance with regards to the anti-money laundering issues. And it also gives insights on customer behavior, helps so that it gives a personalized services and a streamlined compliance process. In retail industry, for example, it mainly benefits on the various point of sale systems and how the social media, how the customer is consuming. So where exactly I'm going and purchasing my data? Am I purchasing my data in Big Bazaar, or am I purchasing from Reliance Fresh? So they're trying to see where exactly a customer is going and purchasing it, and what exactly is purchasing it. Based on that, they'll try to give personalized user experience to you. And in manufacturing and telecommunication, they have all the sensors which will store the production records, and they can forecast any equipment failures. They can schedule the maintenance very proactively, and they can reduce the downtime and the costs. So this enhances the quality control by identifying the defects on the production process. Similarly, in the telecom industry, if you see, they can analyze the network data to predict the outages, and they can improve the service delivery. So these are all the major industries where the AI with the database integration is helping out. In smartphones, I think we saw this earlier as well. It helps in the personalized experiences. They analyze the user behavior and gives the personalized recommendations. Virtual assistants like Siri or Google Assistants, what they do is the NLP models they use, they understand the data that it has, they understand the query that the user gives in, and they respond to the voice commands. The AI-powered apps like when you go for a walk, or when you go for a run, or when you go for a swim, they get all the data stored in your mobile, and they try to analyze the data actually. They also analyze the sleeping pattern today you have, whether are you having a really good sleep today? If not, it's going to create an insight saying that you need better sleep, or you're going to have issues. So these pattern recognition models helps. They also have this fingerprint recognition and face recognition, so that your mobile phone is secure. And one of the key databases, SQLite, which is an embedded database which helps in this lightweight and resource-efficient design in the smartphones. So I think we talked about IoT and edge computing. So basically, because of the proliferation of IoT devices and edge computing, it opens up a lot of opportunities for decentralized data management solutions. So that there is no latency and there is no high network traffic around. Your data is decentralized and it is processed, and it helps in decision making. And the database solutions are tailor-made to IoT deployments. With regards to cloud computing, you have cloud-native database solutions. You have a seamless integration and cost-effective solution. The market opportunities in the market segment is huge now, actually. So because you have exponential growth in data generation, day in and day out, you wake up, you get the data, you go to bed, still you're consumed and bombarded with the data. So the demand for data-driven insights for competitive advantage is so huge. And the need for scalability, the need for security and flexible database solution is also more relevant in today's time. How is the market segmented? If you see, it's an on-prem databases. They have cloud-based database solutions, and it's mixing the both. You have the positives of both on-prem and cloud. You have hybrid based on the deployment models. You also have relational, NoSQL, and a hybrid transaction analysis processing databases as well. And it's based out of end user industries like banking or healthcare or retail or manufacturing or telecom. So across the industries, as data is pouring in, so these are all the ways the data can be captured, managed properly, and efficiently done. Yeah, I think we have seen enough databases in current landscape across from beginning till the end, and how AI and machine learning algorithms can help us to take the data in the future and coming days. That's it I have for today, and yeah, I'm open for any questions and discussion. Thank you.
it's time for the interaction session. If the participants have any doubt, you can unmute your mic and ask your doubts.
Good morning, sir. Hello.
Yeah, good morning, madam. Yeah.
Sir, it's me, Kavita. As you said in your presentation, sir, HTAB, it's a ETL tool. So can you hear my voice, sir?
Yes, I can hear, madam. Yeah, please go ahead. Yeah.
HTAB is a ETL tool. Actually, one more tool is also there, NASA, for ETL Informatica.
Correct, yeah.
Is there, sir? Whether there is any difference between these two softwares, HTAB and Informatica?
No. See, HTAB it's a kind of a meaning. See, Informatica is what it does is it's to get the data, madam. Informatica is what it's an ETL tool. You know what an ETL does is, right?
Yeah.
What ETL does? Yeah, ETL does is it's extracting the data, it is transforming the data, and it's loading the data. And it is loading the data in any kind of database. So primarily ETL is used to store the data. It cannot go store the data in an OLTP database. See, the databases we just categorized into three different. It's an OLTP database, online transaction processing. The next one is HTAB, which is hybrid transactional analytical processing. And the third one is the online analytical processing databases. So that's where in OLAP database is where all your data warehouse, data marts, or data lakes, they reside there. And that's where the ETL part comes in, where you just load all the data from different sources and then you start processing the data. HTAB and ETL is totally different, madam. Yeah.
Okay, sir. Thank you, sir. And your presentation is also very nice, sir.
Yeah, thank you, ma'am.
Thank you, sir. Sir, I think it's me, Kavita, only, sir.
Please go ahead, madam. Yeah.
As you said, the types of database, graph-based database is there, sir.
Correct. Yeah.
As you said that edges and nodes, sir. I mean, edges and vertices. I think it's the representation of ER model diagram in graph is called graph-based database. Am I correct, sir?
No. See, ER model, that is a different graph-based, it's a NoSQL database, and ER stands for a relational database. See, ER is something like entity relationship model.
As you're saying that for vertices, we are going to store the entities, no, sir?
Correct. So, yeah, correct. So here in the relational model, the entity is different. There in the graph database, the entity is also different actually. But the relationships is handled, but the ER which we talk about in the relational model is different, and the ER we talk about in the graph database is different actually.
Thank you, sir.
Yeah, thank you, madam. Any other questions we have, madam? Do you have any questions? The chat box. Muthusili, madam, do we have any questions from the participants?
Sir, shall we find up, sir?
Sure, madam. Yeah, please. Yeah.
Now I invite Mrs. P. Kalishwari, ma'am, to propose the vote of thanks.
Good morning, everyone. I am pleased to convey my gratitude on behalf of our college and department, our chief guest, Mr. Rajesh Kumar Arjuna, who is the key source of accepting our invitation and making his FTP happen today. Your talk not only have us knowledge about data evaluation, AI and ML influence, but also gather the knowledge about IoT, edge computing and cloud computing. We get an idea about market opportunities and market segmentation, which we are clearly understood from our session. Thank you, sir. I would like to thank all the participants who not only took your time but also cheer us to keep moving with session like this. Let us meet more at the same time. Until then, thanks all. Have a good day. Thank you.
Thank you, ma'am. Thanks, everyone, patiently listening to the presentation today. And thank you for this opportunity again, RRC college staff and the management. We really appreciate all your efforts, madam. Thank you.